So this is my synthetic chemistry project. I did my project on self-healing concrete. So self-healing concrete actually has two different bacteria. The first one, the Sobra, I don't even know how to say that, or Bacillus pasteurii. And that is actually, it's the actual bacteria that is actually healing the concrete and filling in the gaps. The calcium lactate is it's kind of the food and what helps the other bacteria be able to grow. So the problem is that concrete is used half of everything, majority of buildings use them for you can use them in walls, you use them for you use them on floors, you use them for foundations, they are used everywhere. And so when you're making concrete, you pretty much, it's just a chemical reaction. You have to get the recipe and process right, and it's really hard to know if there's going to be damage or not. And when damages come, it's really expensive. So the solution is that this this bacteria and the stuff it feeds on, you just put it in with the concrete when you're making it, and then it will be able to fix the repairs without aid. So then you don't have to really monitor all the time, and it even gives 90% of the strength back. So you don't have to worry about it cracking as much anymore. The solution, the bacteria in the food, the thing that it feeds on, it will last up to 200 years. So that's a really long time that you can have it be there to be able to heal it. And then because most damage you can't see, this could save lives from an earthquake or in other natural disasters, because you can't check for everything. A lot of damage goes unnoticed. So if it's able to just heal itself, then then it will possibly save lives because it's going to be fixing itself. Also, so the bacteria that I give you is the one that I found the very first one I found, but as I was doing more research, I saw there were lots of different bacteria that we used. And then lastly, help protection against freeze attacks. So just if it's another thing with concrete, it will freeze really fast, and then it will melt and it will crack. So this will help help fix that. Consequences. So it's it's very expensive to first of all do it. We're gonna have to find a way to be able to get that to be a lower price. And I mean, yeah, it does take a lot of money to fix it, but sometimes if the solution is right, you don't even need the solution that will fix the concrete and heal the cracks, because it's already fine. And also, to investigate and get this to be able to be used in everything will cost money. Like I said, it does get back strength, but it's only 90% of strength. So in tall buildings that the concrete is really relied on, it won't really help with stability as much. It does increase the concrete volume, so that will cause problems when you're making it. The bacteria won't grow in every environment, and it won't heal huge cracks. So that's not a huge problem, but that is still a problem that you have to know that's there. So the big picture is that will minimize the cost and time of making concrete and fixing it. It will increase safety. It will monitor itself, and so you won't have to be fixing it. You won't have to be looking at everything, checking for all these different cracks. It will just be healing itself. It will create durable roads and buildings. It lasts longer and it will heal itself. It will last longer because it will heal itself throughout time. And again, it can prevent death and from other natural disasters. So here are all my works cited, and that's all I got. Thank you.